Okay, today we're going to start talking about 13.2 in our textbook, which is on permutations. Our essential question for today: how do we know when a permutation is needed for a real-world situation, and how do we calculate a permutation? So we're going to start with a little bit of terminology. So a permutation is an arrangement of objects in which order is important. And that key phrase, arrangement, or key word, is going to be very important in determining whether or not we need to use a permutation in a real-world kind of situation. So that arrange is very important. Next is a factorial. So a factorial is the product of integers from 1 to n. So when we write it, it'll look like the 5 factorial. We use an exclamation point. In math, that exclamation point is called a factorial. And that means that you start at 5 and then you multiply everything below it. 5, 4, 3, 2, 1. And then you always stop at 1. One thing to note that's very important is that 0 factorial is equal to 1. So anytime you get 0 factorial, that's automatically equal to 1. So now we're going to look at how to find the number of permutations. We're actually going to do some calculations here. So when we want to do a permutation of all the objects, then we write it like this: npn. So the first number is the total number of objects. And the second number is how many of them you are rearranging. In this case, we're wanting to rearrange all of the objects. So when we do that, we do n factorial. So we just talked about what factorial is, so that means you would start at the number n, whatever that number is, and multiply everything below it. So here we have an example. We have 4 objects, and we are wanting to rearrange all 4 objects. Then that would be 4 factorial, and 4 factorial is equal to 4 times 3 times 2 times 1. So to calculate, you would multiply. So 4 times 3 is 12, 12 times 2 is 24. Another example, a locker example. So typically for any locker combination, careful with the word combination, you'll learn more about that next time. There are 3 numbers, and to open the locker, the numbers have to be in a certain order. That's one of the key ideas with permutations, is that order does make a difference. So we have to make sure that we get those 3 numbers in the correct order. So if we are taking all 3 numbers and rearranging them to try to figure out what the correct combination is, given 3 numbers, that would be 3 factorial. And to find 3 factorial, you go 3 times 2 times 1. Multiply those together. 3 times 2 times 1 is 6. So there are 6 different ways that we can rearrange those 3 numbers to find the correct locker code. So now we're going to take a look at doing a permutation where you have a total of n objects, but you are only selecting r of those objects. So r is another number, n is the total, and your number r should always be smaller than the number n. So our notation, n is the total number of objects, r is the number of objects you are selecting, and then the formula to calculate that permutation would be n factorial on top, and then you divide by n minus r factorial on bottom. So first you subtract n minus r, and then whatever number you get, you're going to do the factorial of that number. So let's look at an example. If we are selecting 3 out of 5 objects, so 5 is the total number of objects, so it would be 5p, and then our r is 3 because we are selecting 3. Again, the 5 is the total number of objects. The 3 represents how many you are selecting. And the P is that we have selected to do a permutation, that the order of these objects does matter. So using the formula, it would be the first number factorial over the difference of these two numbers, 5 minus 3 factorial on bottom. So you need to show your work, show that you've plugged the numbers into the formula correctly, as you see here. Next, write out what that represents. So do the subtraction first. 5 minus 3 is 2 factorial. Then do the factorial parts. So on top, 5 factorial is 5 times 4 times 3 times 2 times 1. So we're going to write it all out. On the bottom is 2 times 1, since it's 2 factorial. And then we do some simplifying. So you have a 2 and a 1 on the bottom and on the top. So 2 divided by 2 is 1. 1 divided by 1 is 1. And so all you end up with is 5 times 4 times 3. And 5 times 4 is 20. 20 times 3 is 60. There are 60 ways to select 3 objects out of the 5. Next example is what I call the advisor example. So a few years back, in advisor, we had to select a representative and then an alternate if the representative could not make it to ASB meetings. So it did make a difference, the order in which they were selected, because whoever was the representative was required to attend these meetings, where the alternate only had to show up if the representative could not make it. So different job duties for these two individuals. So I had 14 students, and we were selecting 2 of those students because the order made a difference. This is a permutation. So we would set it up. Total number goes first, so that's the 14. P, and we are selecting 2, so that number goes second. Now we're going to set up our formula. So on top is the n, which is 14, so 14 goes on top. 14 factorial. On bottom is the difference between those two, so that would be 14 minus 2 factorial. Important that you keep parentheses around it. So next we're going to write it all out. Now some of these numbers are pretty big, so I'm going to, in the process of doing this, show you one shortcut that you can do when the numbers get really big. You still have to show your work, so show the formula part first, which you see here, 14 factorial over 14 minus 2 factorial. Then we're going to start writing it out. Let me first do the subtraction. So 14 minus 2 is 12 factorial, so we have 14 factorial on top, 12 factorial on bottom. So on top we're going to start doing the 14 factorial, which is 14 times 13 times 12 times 11 times 10 times 9, 8, 7, 6, 5, 4, 3, 2, 1, all the way down to the 1. But instead of writing all of that, I'm going to stop at the 12, and I'll explain why in a second. Now note, at the end of the 12 I put a factorial. That factorial is only on the 12. Remember, the factorial means that we start with 12, and then it's 12 times 11 times 10 times 9 times 8, 7, 6, 5, 4, 3, 2, 1, which is the rest of the 14 factorial that I'm not writing. So when I write that factorial, that includes all those other numbers from 12 to 1. When we look at the 12 factorial on the bottom, that's the same as 12 times 11 times 10 times 9, 8, 7, 6, 5, 4, 3, 2, 1, all the way down to the 1. So that 12 factorial will stay at the bottom. And then notice we have a 12 factorial on bottom, a 12 factorial on top. They mean the exact same thing. 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So since it equals the same thing, and we have it on top and bottom, that would equal 1. 12 on top, 12 on bottom is 1. 11 on top, 11 on bottom is 1. So all we have left is the 14 times 13. Make sure that when you use this method, don't forget that factorial at the end on the top and the bottom. It's a very important piece. That indicates that there are still numbers that come after the 12. So you need to have it in both cases. Now finishing up, 14 times 13. So there are 182 ways that we could select 2 students out of the class of 14. So next I want to take a look at a couple of questions. The first Which permutation formula would you use if you had 3 students standing in a line and you wanted to know how many arrangements there are for lining up all 3 students? So remember, there were 2 permutation formulas. There was the n factorial formula, and then there was the n factorial divided by n minus r factorial. So the question here is asking, which of those 2 formulas would you use if you had 3 students standing in line and you wanted to know how many arrangements there are for lining up all 3 students? So that's one of your keywords there, is the all. Another keyword is arrange. So the arrange tells you that you're doing a permutation, and you're doing a permutation with all of the students. So this formula was the one that we used when we do all of the students. 3p3, since we're arranging all of them, that would be 3 factorial. Remember, 3 factorial means 3 times 2 times 1. So we multiply those together, 3 times 2 times 1. That gives us 6 ways to arrange all 3 students. Next question. How can you tell that order is important in the above example? So we actually talked about this. I mentioned it as we were going through the example. So we're looking for some keywords. What are some keywords that lets us know we're using a permutation? In this case, the word arrange tells us that we have a permutation. Some other keywords might be first, second, third, so that you know there is an order, or different kinds of job duties, president, vice president, secretary, or any kind of phrases that indicate there is a certain order to the arrangements, different prizes awarded for different drawn numbers. So as you draw a number out of a hat for a drawing, if a different prize is awarded each time, then the order in which those numbers are drawn does make a difference. So you got to remember all those keywords, and if you see them in an expression, that will help with identifying whether you have to do a permutation or not. Be sure to take some time to write your questions in the left column, as well as answer the essential question at the very end of your notes. And we'll do some more practice in class next time.